So I'm going to talk about our work. It's a joint collaborative work together with collaborators from TU Darmstadt and company in Germany called Kobil. And we designed here the system which uses federated learning and enables mobile service providers to share information risks in a privacy-preserving manner. So the motivation behind this work is the fact that mobile service market is growing, and the situation. So many services are available using mobile phones, and the situation got even sped up by Corona pandemic, because in Corona many businesses which were before offered only in physical domain moved to digital, right? So, and this creates additional attack vectors, because you can imagine that such vendors, they have maybe not enough resources, no expertise in security, and also under pressure time to market, and they release quite often software which is not well protected against attacks, and this is what we want to, so to say, improve in our work. So it appears that dealing with mobile threats is not easy also for experienced service providers, because kernel level protection mechanisms are not really available. They are under control of operating system vendors, and interfaces are not exposed to applications. The same applies to the hardware mechanisms. For example, there is no Intel SGX on mobile devices, and also if we have other security capable chips, they are typically also controlled by stakeholders such as network operators, also not available. And as a result, network service providers in mobile domain, they have to resort to application level protections, where they design intrusion detection systems and risk monitoring and analysis. And in our work, what we wanted to answer as a research question, can we eventually transfer the knowledge which was built by experienced service providers to those who are newcomers? So small, medium-sized enterprises, can they benefit from such systems? So at the moment, these solutions are out of reach for them, but can more experienced service providers share the knowledge and make them capable to detect advanced threats? So when we look at the related work, we may notice that such sharing systems or similar sharing systems exist, not in the mobile domain, but for service providers, network service providers, for example, and they are called cyber threat intelligence systems. They share information of different types, structured information and unstructured, such as incident response, IP addresses from where attack was detected, different kind of log files, emails, if they are, for example, were detected to appear in the phishing campaign. So this information is called indication of compromise. However, CTI systems, they have challenges to deal with. First of all, they are difficult to manage and complex, and as a result, they are only available to large service providers. Then there is problem of interoperability and automation, because it's hard to deal with this kind of large amount of unstructured information. And there is also privacy issues, not last but not the least, because even just revealing information about an incident in company may damage the reputation. This is why many companies do not participate in such systems. So the contributions in our work is, first of all, we automate the process of risk detection by leveraging deep neural networks. Second, we develop and deploy the system which is called, we call Cyber Risk Intelligence platform, which is intended for sharing of risk information. And instead of sharing indicators of compromise, how currently is done in cyber threat intelligence systems, we share machine learning models, and this is a more privacy-preserving way to do so. And we also evaluate our system on a very large data set coming from our industrial partner, and I think this data set is also an interesting aspect of our work. So let's look how risk monitoring is done. So risk monitoring is something which is already exists in the industry. Typically, mobile apps, they consist of server part and the application. If the app deploys a risk monitoring component, then the app is split in two parts, and each part has corresponding server part. And when the application logic detects security-sensitive context, it can communicate to the risk monitoring or management and ask for risk prediction and then take the corresponding action. And what kind of risks could be detected? For example, operating system level risks such as device jailbroken or malicious binary is detected. Application level risks if there is, for example, malicious app detected. Environmental risks if the app detects that it is, for example, executed in the container, so it could be indicator that it is reverse engineered. There are challenges such as many false positives, and typically it is dealt with by manual involvement of security experts who are in the loop and can facilitate the decisions taken by the system. So now I'm going to show the machine learning pipeline which we developed. So it starts with data cleaning, so where we deduplicate the data, remove erroneous records. Then we perform feature selection, and we identified that in addition to those risks which are reported, it is also very useful for classification results to include information such as application version, operating system version, platform type, and CPU architecture. Then we perform labeling of the data. It's performed manually, and we define 4 labels for classification, like high risk, medium risk, low risk, and false positive. False positive means that the system reports it as a risk, but after manual analysis, it appears to be false positive. Then we perform typical data processing such as data shuffling, tokenization, word embedding, and prepared data is then fed to the machine learning model. We use recurrent neural networks, and then we iteratively train and validate and test the network results until we achieve good performance, and then the resulting model can be used for inference. And then this model, which I showed on the previous slide, it is going to be integrated into the cyber risk intelligence platform. This platform leverages federated learning to model and share risk information. So we have here security provider, trusted party, which provides interfaces to service providers such as payment providers, online banking systems, etc. And each of the providers collect risk information from their users, and they build local data sets, train local models, and those local models are then uploaded to the cyber risk intelligence sharing platform, which then builds generates the aggregated model, which is redistributed back to the clients. And additionally, here it is possible for parties to participate who didn't participate in model building. They could benefit from results produced by other providers, and for example, they can be part of the system on a subscription basis. So in operation, the platform functions like as follows. So here we have the end user who provides information about platform risks. So this information is collected by the service provider, and then the data set is built, which is used to train local model. Then this local model is uploaded to this aggregation server. Then when collected from several or like all providers, then the model is aggregated and the aggregated model distributed, and then it could be used for detection when, for example, some security sensitive operation happens, for example, user login. And then the application part of the service provider can make a decision if the security sensitive action could be allowed or denied. So now I would like to show some details about our data set. It includes a total of 23.8 million of users, and it was collected in European countries over the course of 6 years. So here we have 9 service providers participated. They are from financial services, payments, insurance companies. So this table shows the division of the data set. So this is, so for example, here we can see that they are also distributed not unevenly. For example, we have very large providers with like more than 12 million records, and also small providers with 4K records only. And here the risk monitoring is reported for 3.8 million users, and after manual labeling we identified that more than 3 million of them are eventually false positive. So you can imagine that it's like quite a large number of false positives for a production system. So here I would like to show the performance of our federated model. This slide depicts the performance of the model. So for example, if we consider the provider A, it performs very well. Local model of this provider performs very well. So this is the local model of provider A, but performs poorly if local models of other providers are used, but the federated model performs equally good. And we can see that the trend continues for different providers. Just here for providers K and L, we see a little degradation, so we don't achieve here 100. So F1 score not 100, but a little bit less, like 98 and 97%. So also remarkably, our model delivers very low rate of false positives. So here those tables, they provide false positive rate, true positive rate, and false negative rate for all the providers. We can see, for example, that the false positive rate is very low, and if we have the average over all service providers, we stay under 2%, and this is very good result compared to the previous situation. So to conclude, we present a federated cyber risk intelligence solution for mobile platforms, and it tackles the challenges of existing cyber threat intelligence systems. It enables sharing risks in the form of machine learning models. It utilizes federated learning to improve privacy of sharing information, and it achieves very good performance in terms of detection, like 99% of F1 score, and also has remarkably small number of false positives. So that's it from my side. Thank you very much for the attention, and I'm ready to take your questions.